The pathogenesis of atherosclerosis can be explained by several factors that can cause endothelial injury. Those factors are associated with endothelial dysfunction, which leads to increased vascular permeability, leukocyte adhesion, and thrombosis. Endothelial injury is usually followed by accumulation of lipoproteins, mainly the oxidized LDL and the cholesterol crystals. Those accumulate in the vascular wall, and this will result in platelets adhesion and monocytes adhesion to the endothelium. So the monocytes then will start to migrate into the intima, which is the innermost layer of the vascular wall, and differentiate into macrophages and foamy cells. As I said in the previous slide, and this will be explained more in details in the upcoming two slides, several risk factors, including the minor and the major risk factors that we discussed before, can cause endothelial injury, which is associated with endothelial dysfunction leading to increased vascular permeability, leukocytes adhesion, and thrombosis. This is usually followed by accumulation of lipoproteins in the vessel wall, then platelets adhesion, monocyte adhesion to the endothelium, and migration. Then the lipids starts to accumulate within the macrophages, which start to release inflammatory cytokines. Those cytokines will result in smooth muscle recruitment due to those cytokines that are released from the macrophages and also released from the activated platelets and the vascular wall cells. All of this will be followed by smooth muscle proliferation and extracellular matrix development and production. This figure shows the steps of response to injury in atherogenesis. The figure at the top shows a normal vascular wall, which is made of the innermost intima, the middle media, and the outermost adventitia. Here, this vascular wall is exposed to chronic endothelial injury, which can be caused, as we discussed before, by hyperlipidemia, hypertension, smoking, homocysteine, hemodynamic factors, toxins, viruses, and immune reactions. I mean the major and the minor risk factors that we discussed before. The second figure below shows the vascular wall after chronic endothelial injury. So this vessel starts to respond by increasing the vascular permeability in one hand, and then the monocytes and the platelets start to adhere to the vascular wall and immigrate through. This is usually followed by more intimal smooth muscle proliferation and extracellular matrix deposition, forming the well-developed plaque that we discussed in the initial slides, when we say that the plaque is an intimal lesion composed of a fibrous cap and central core that is composed of cellular debris, cholesterol, and cholesterol ester, and strengthened by those smooth muscles in the fibrous cap, added to it the extracellular matrix material.